everyone. Welcome to another interesting session of the Wisdom Channel. Yes, this is Mohammed Shamim, the infrastructure architect of Isbat University, and a cloud specialist, also a cybersecurity specialist. This is going to be a very interesting session. Yes, I'm going to take you through AWS Cloud Foundation. Eventually, you're also prepared for an exam for AWS Cloud Foundation. This is going to be a series of sessions with different modules, but today you're going to discuss about the module 1, which is a cloud concepts overview. In the meantime, please subscribe to the channel and make sure that you have clicked the bell button icon so that you get the notification about the other sessions. So in module 1, cloud concepts overview, we are going to look at the section 1, introduction to cloud computing. So what is cloud computing? A cloud computing is an on-demand delivery of compute, power, storage, database, applications, or any IT resources via internet. And it is also a pay-as-you-go. So as I told you, in-demand, pay-as-you-go. In a nutshell, cloud computing is something that we host or someone hosts services somewhere which we can lease it to access it from anywhere and everywhere. That's what we call it as cloud computing. It is something like an infrastructure. In a different language, I can say cloud computing as infrastructure as software. The cloud computing will enable you to stop thinking of your infrastructure as a hardware and instead think it as a software. Usually, what is a traditional computing model? Infrastructure as a hardware. So, what did I tell you here? Cloud computing is to make you stop thinking your IT infrastructure as a software instead of thinking as a hardware. When you think it as a hardware, I can call it as it's a traditional computing model. Infrastructure as a hardware. The hardware infrastructure that you need to build needs colossal amount of manpower, planning, hardware. Eventually the hardware comes with a cost, operating system licenses, and it also needs a procurement life cycle. So building an infrastructure as a hardware is not that hard, but it is hard, and eventually the IT managers or the IT personnel can make errors or flaws which cannot be rolled back. Let me give you a good example. You are responsible to get build up an infrastructure. Something went wrong and your planning didn't go very well. The hardware that you have invested on, either it is going to be redundant or it's going to be overused or underused. Eventually, you're going to have a tough time with the management when the suggested hardware may not, if it has not served the purpose. And it needs security, and you have to be you need to be more about security of protecting that infrastructure from any attacks. And it has a lot of efforts. And being an infrastructure admin, maybe you will have a lot of sleepless nights. Do you know that most of the problems comes to an IT personnel and an IT administrator at Friday evening? So that I don't know how a server can sense that it is a Friday evening, so that it doesn't allow the infrastructure admin not to sleep on Saturday and Sunday very well. These things can be avoided by moving into the cloud computing model, which is the infrastructure as a software. Infrastructure of the softwares are flexible, can change more quickly, easily, and cost effectively than hardware solutions. It's something like taking a photo, and if the photo has not come very well, you take another photo. The process or the time taken for you to go from one photo to another photo is what is going to be happening when it comes to using a cloud service model. That is your infrastructure as a software. You run a hardware, you have seen your application is struggling to run, you can switch it from one hardware to another hardware. If an operating system is not handling that particular application very well, you have a choice to use different applications. And if you want to be adding any accessories or any other components into your infrastructure, it can be added seamlessly. That is a good thing with a cloud computing model. We have different cloud service models. The cloud services are offered in different models: infrastructure as a service, platform as a service, and software as a service. Next we are going to discuss about the advantages of cloud computing. Let's talk about a trade capital expense for variable expenses, right? Data center investment based on forecast, pay only for the amount you consume. Let me give you a good example. I have some money. When I need to build a infrastructure with the hardware, I'm not very sure that the hardware which I am building now is going to be completely used. Yet, certain amount of money what I have invested is accumulated there. So they cannot sell in pieces. So, for example, if I'm buying a server, the server needs 40 GB RAM and memory of 40 GB. But when I go there, it's a small example, but when I get it, I got it for 64 GB RAM, and the other things are being, the money what I invested for 64 GB is redundant now. But when it comes to the cloud computing and the cloud computing models, you pay for what you need, for what you consume. So end of the month, your expenditure is almost equal to what you have used for. There's no redundant expense. There's no stock accumulated in your infrastructure, which still carries asset value. Basically, it is something like you buy a service, you use it. When you don't need it, you can stop the service from the very day. Is one of the greatest advantages of cloud computing. Another advantage I can talk about is stop guessing the capacity. To build an infrastructure, you don't need to guess your capacity. It could be this, it could be bigger than this. What if I made a choice which is lesser than? Most of the IT infrastructure cost goes on by guessing, because the administrator even may not know, the IT personnel may not even know the hardware is going to procure, is going to serve the purpose. So to be on a safer side, he always go on a higher level. That's a guessing. Eventually this can increase the budget, the spending of an organization, which is nowhere to be known, but the organization has to feel this cost as an expenditure. Sometimes it's going to be overestimated, sometimes it's going to be underestimated. There's no proper scaling within traditional IT infrastructure. But when it comes to a cloud model infrastructure, you have a scaling, you have your budget in control. And you can also analyze your expenditure and see, is my hardware which I have subscribed last month, is it being used or it is not used, so that you can reduce it. And most of these cloud services has a billing capacity to bill what is the amount of resources you use. It's not stagnated to a resource itself. The amount of resource, what is the processor level you used for a month, the memory level you used for a month, what was the traffic you expected on a month. So I can say that the second advantage of cloud computing is stop guessing the capacity and go with what you need at that moment. The next advantage is increased speed and agility. Let me give a small explanation on this. What would be the time taken for an infrastructure from an inactive state to an active state? A time taken for an infrastructure to be built. We need the components, we need to order them, we need to get the approval, we need to get the correct costing from the correct supplier. It has to be purchased, it has to be manufactured, it has to be shipped, it has to be arrived, and you have to configure it. The time frame for you to have the point of time when you need the resource versus the time you got that resource in hand is not that simple, it's more. But here in cloud services, it's just by clicking a launch button, an active button. You need your instance, you need whatever things you want, and you click launch, you have your instance in front of you in no time. Stop spending money on running and maintaining data centers. Running a data center is not easy. We have to look at various things. We need to look for redundant power. We need to have a continuous internet. The computing resource has to have a disaster recovery, backup. And you need to plan very well for the cyber threats, the firewalls, the components. A data center is not just built in a day. It has to be meticulously planned and designed, which is going to have a colossal spending from an organization. Any organization who is trying to, either it's a startup or any business which has been coming into the business, they need a proper IT infrastructure which needs a lot of cost. And maintaining a data center is also another cost. But when it comes to these cloud model concepts, you don't need to worry about anything. You just try to lease it to someone. Just say, take care of my servers. Let it run on your platform. And I need it whenever I need it. And I'm going to pay for it for this particular service. And you can sleep very well at home thinking no need to worry about how your infrastructure is running. The next advantage we are going to talk about is go global in minutes. Hope you got that word, go global. Get yourself exposure to the whole globe. That if you're launching a service, for example, a website and an application, you can go in minutes with using cloud services rather using the traditional. Yes, it's possible, but it's not in minutes, maybe in hours. You need to have an internet, we need to have a public IP, we need to write a NAT rule where we need to forward the traffic, then we need to buy the domain name, we need to do all these activities, then you launch the application, it has to go for testing, and it also needs a propagation time of DNS servers. It all looks more sophisticated when you need a service online. With cloud, you are launching a service which can be globally accessed in a millisecond. Is it that interesting? So till this minute we have been talking about what is cloud computing and its advantages. Let's go into the core. Let's introduce Amazon's web services. What are web services? A web service is any piece of software that make itself available over the internet. It could be an XML language, extensible markup language, or JavaScript. It is something like an API interactions, that anything that you can interact to an application over an internet, which is launched over through a browser, is what we can call it as a web service. What is AWS? AWS, Amazon's web service, is a secure cloud platform that offers a broad set of global cloud-based products. AWS produces you with on-demand access to compute, storage, network, database, and other IT resources and management tools. AWS offers flexibility. You pay only for the individual services you need for as long as you use them. AWS services works together like building blocks. There are different categories of AWS services. It's not that AWS is just a computing service alone or database service alone. It is also a pre-built applications. As you can see, the categories of AWS services, it can be the applications are available to do analytics, application integrations, AR and VR, blockchain, business applications, compute, cost management. You can name it. I can name it a few, but there are many things, and I'm just going to take you through it. Basically, any infrastructure need. If you want to be introducing a certain kind of artificial intelligence component into your application, you don't need to go behind for looking for a developer who has to develop a component, an element where you write algorithm or anything, right? You can start using their services in a very short time, developing a game, getting the satellite data, end user computing, right? Machine learning. I'm saying that any services on earth which can be done through an IT infrastructure in a traditional infrastructure can be purchased as a service from AWS. You can see a simple solution example where we have the users accessing a VPN where that VPN gains same access to the networking, compute, database, storage. Everything is in on a nutshell. As you can see here, we have different types of instances. It has its Amazon has its AWS has its own database. Everything that you just dial a VPN and start using its resources. So choosing a service, the service you select depends on your business goals and technologies requirement, right? You can use different instances like VMware Cloud on AWS, Amazon's AWS Lambda, Elastic Beanstalk. You can use Amazon Lightsail, AWS Badges, Outpost, AWS Fargate, Amazon EKS. Whatever you can choose, it depends on what your technology or business needs. So what are the services covered in this course? In this course, in the series of sessions, I'm going to cover you all the compute services, all the security, identity and compliance services, storage services, database services, networking and delivery services, management and governance services, AWS cost management services. Let's have the module in brief. Services covered in this course. The next we are going to see the cloud adoption framework. The framework that someone should handle before they move from the traditional IT infrastructure to the cloud infrastructure. The AWS Cloud Adoption Framework is made of 6 components. The components are business, people, governance, platform, security, and operations. For a successful cloud adoption, we need to take care of all these 6 components where AWS is trying to adopt it with a guided framework. So this AWS Cloud Adoption Framework provides guidance and best practices to help organizations build a comprehensive approach to cloud computing across the organization and throughout the life cycle to accelerate successful cloud adoption. The components, the 6 components, once again, the business, people, governance, platform, security, and operations. Where the business, people, and governance comes under the business capabilities, whereas the focus of technical capabilities is platform, security, and operations. Let's talk about the business perspective. We must ensure that the IT is aligned with the business needs and the IT investments can be traced to demonstrable business results. Any deployment that we try to make should be in the perspective of business, where the framework also supports what are the things that we need to adopt: the IT finance, the IT strategy, benefits realization, business risk management, basically the risk management. These are the business perspective capabilities. So this framework supports the business demonstrations. So the next is the people perspective. The people perspectives are the people are resource management, incentive management, career management, training management, organizational change management. People perspective capabilities are classified as this. We must prioritize training, staffing, and organizational changes to build an agile organization. So the framework also says that the proper training has to be given, or the staffing has to be done for an organizational changes to build an agile organization. So the framework also adopts the people's perspective. The governance perspective, which is a portfolio management, program and project management, business performance measurement, license management. We must ensure that the skills and processes align IT strategy and goals with business strategy and goals. So the organization can maximize the business value of its IT investment and minimize business risks. That's what basically the governance. Now are the technical perspectives. We have platform perspective, where compute provisioning, network provisioning, storage provisioning, database systems and solutions architecture, application development. We must understand and communicate the nature of IT systems and their relationships. We must be able to describe the architecture of the target state environment in detail. Basically, in platform perspective, we are going to choose what we needed to run our application seamlessly. Is a framework where the platform perspective talks about. The next is the security perspective. where we have identity and access management, who should access what, when they should access it, detective control, infrastructure security, data protection, incident responses. We must ensure that the organization meets its security objectives. That's a framework which is talking about the security perspectives. The next is the operations perspective, where the operations like service monitoring, application performance monitoring, resource inventory management, release management, reporting and analytics, business continuity, disaster recovery, IT service catalog. We align with and support the operations of the business and define how a day-to-day, quarter-to-quarter, and year-to-year business will be conducted. Basically, this framework is how you should manage, how you should monitor, how periodic you should monitor, what are the inventories that you have to be working on is mostly being covered under this operations perspectives. So these are all the 6 perspectives. Once again, in a nutshell, the 6 perspectives of business, people, governance as business capabilities, platform security operations as in technical capabilities. So this is what is covered in the CAF, Cloud Adoption Framework. We are coming to an end. We are wrapping up today's session. Let's get in summary of what we have discussed today. In summary, we have defined different types of cloud computing models. We have described the advantages of cloud computing. We have recognized the main AWS services, what are the services is offered under AWS, and we also discussed about the AWS Cloud Adoption Framework. Today, we have covered about the cloud concept overview, which is one of the module in your AWS Cloud Foundations. Hope you enjoyed the sessions. Any doubts or any questions, you can just post it on the comment. I'll be happy to help you out, right? So let's meet on session 2, which will be published shortly. Thank you.